Nearly every piece of agent security advice tells you to harden the model. Train it to resist bad prompts, filter its outputs, patch the weights. Researchers at Google DeepMind argue that misses the point. In a paper posted late in March, they mapped a whole taxonomy of attacks that never touch the model at all. They target the environment the agent moves through. They call them agent traps, and today we're walking through the 6-category framework and why it's a different lens than the trifecta or corpus poisoning. Start with the agent operating cycle. Every autonomous agent loops through the same basic stages, and the DeepMind team showed there's a trap waiting at each one. It begins with perception. The agent reads its environment, a web page, a screen, a document. Hidden HTML injections live here, and researchers found they hijack agents in up to 86% of the scenarios they tested. Next comes reasoning. The agent plans what to do next. Attackers plant misleading cues in the environment that steer that plan sideways, so the agent talks itself into the attacker's goal. Then there's memory. Agents store notes for later. Latent memory poisoning slips a payload into that store, and researchers report over 80% success at less than 0.1% data contamination. Finally, there's action. The agent takes a step in the world, clicks, sends, calls a tool. A trap here turns a legitimate-looking action into the attacker's move, all inside a normal-looking task. The full paper names 6 categories, mapped across perception, reasoning, memory, action, multi-agent coordination, and the human supervisor. Here are 3 representative ones to make the idea concrete. Perception traps. Hidden instructions embedded in what the agent looks at, invisible to a human reviewer but read straight into the model's context as if you had typed them yourself. Memory traps. Poisoned entries planted in long-term storage that lie dormant, then fire on a later, unrelated task. Tiny contamination, durable effect because the agent trusts its own notes. Coordination traps. In multi-agent systems, one compromised or spoofed agent feeds bad state to the others, and the human supervisor at the top can be manipulated into approving it. So here's the reframe the paper is really arguing for. Harden the model and you're defending the wrong surface. Better weights and stronger refusals help, but the attacker never fights the model directly. They edit the world around it so a hardened model still walks into a trap someone laid in its environment. Harden the environment and the cycle instead. Verify what the agent perceives, isolate its memory, gate its actions, and audit the coordination between agents. The DeepMind thesis is that attackers alter the environment, not the model, so that's where the defense belongs. Okay, for takeaways to lock in. Agent traps are Google DeepMind's taxonomy of environment-side attacks, posted in a paper late in March. The taxonomy maps 6 categories to the operating cycle: perception, reasoning, memory, action, multi-agent coordination, and the human supervisor. Hidden injections hijacked agents in up to 86% of scenarios. Memory poisoning topped 80% at under 0.1% contamination. Defend the environment, not just the weights. For more agent security breakdowns in plain language, head over to Standarity.com. See you in the next one.